We all love the company of our favorite people. Similarly, hydrocarbon chains are also fond of other molecules. They get bonded so strongly that the properties of the compound change depending on the molecules attached. And what are these groups of molecules referred to as? They are called as the functional groups, that's right. Let's get to know about them. Beginning with the definition first. How do we define them? In simple words, these are the groups of atoms that give characteristic properties to the compounds in which they are present. Yes, their presence is quite influential. If they're a part of a compound, the entire compound takes its properties. Have we come across any of the functional groups ever? Yes, we've heard many names like alcohols, phenols, ethers, and so on. Look at the structures carefully. What do you notice? It helps us understand that they have atoms which can form at least one bond with any other atom. Yes, at least one atom in the complete group is ready for bond formation. Let's understand this in a simple way. Say we focus on the structure of alcohol. This functional group has one oxygen atom and one hydrogen atom. That means a hydroxyl unit is what makes up the alcoholic group. Can you notice that we've drawn a line before oxygen here? What does this indicate? Well, it indicates that the group is available for bond formation. So there can be any other atom bonded to the oxygen atom of this hydroxyl unit. So if I take any carbon chain, say something like this, then we can attach the alcoholic functional group at the carbon atom which is available for bond formation. And the new compound gets formed in this way. Similarly, talking about the functional group carboxylic acid, its structure is somewhat like this. Represented as dash followed by COOH. The group contains one carbon atom. Out of the 4 bonds that it can form, 3 are already formed. As we can see here, one oxygen atom is attached to the carbon atom with a double bond, while another single bond is with the hydroxyl group. This is how we get COOH as our carboxyl group. Now from here, where will this group be attached to the hydrocarbon chain? Yes, from the carbon atom. And why is that? We know that the valency of carbon is 4. 3 bonds in the functional group have got formed, leaving behind just 1. That is why the line is drawn before the carbon atom, which indicates that the group can be attached from here. Where do you think will this group be attached? It can be attached to an alkyl group. Wait, what do we mean by an alkyl group? We've seen what alkanes, alkenes, and alkynes are. Single bonds, alkanes. At least one double bond, alkenes. And at least one triple bond, alkynes. So what is an alkyl group then? Let's take an example of ethane to understand this. We can see that each carbon atom here has its valencies completely fulfilled. 4 and 4. However, if we remove even one hydrogen atom, then the group becomes capable of forming bonds with other compounds. Like in this case, it can bond with a functional group from this point. This thing that you see here is an alkyl group. It is just derived from an alkane by removing one of its hydrogen atoms. That's all. Here it's derived from ethane. Hence it's called an ethyl group. Similarly, if we remove one hydrogen atom from methane, it will be called as methyl group. Alkyl groups are usually represented with the letter R written in uppercase. This was a general overview of what alkyl groups are. But the main topic of this video was functional groups. They're a group of atoms that give characteristic properties to the compounds in which they are present. The entire compound takes its properties. Let's have a look at a few more interesting examples of functional groups in the next video.